Okay, Algebra 2 fans, we will be using these linear models that we've been talking about. Okay, so we've really got to get down being able to graph. We really need to understand how to go back and forth between different forms of the equation. But it's really important in several of these examples, we really need to understand how to use this in a story problem situation. So for instance, the slope, remember that is the rise over the run. That's going to be quoted to you in like miles per hour, feet per second, gallons per minute, those type of things. Anytime I hear something like that, miles per hour, gallons per minute, those type of things should be setting off bells and whistles in my mind that they are giving me the slope of the line. Now, B represents the y-intercept, and that is the y value when x equals 0. Now, if x represents a time, that's when the time is 0. If x is a distance away from my classroom for something, then 0 would represent being at my classroom. Okay, but whatever x represents, 0, plugging in a value of 0 for x, as we talked about in the last video, that is the part that really that you need to understand. When x is 0, then you get the y-intercept, and that's really like a starting amount. So for instance, the book example 1 talks about, it says Jacksonville, Florida has an equation of 12 feet above sea level. So Jacksonville, Florida sits 12 feet above sea level. Well, that makes sense because Jacksonville, Florida is close to the ocean. We obviously are a lot further away from the ocean, and we are a lot higher than that in terms of our sea level. But that is the starting amount. A hot air balloon taking off from Jacksonville rises at 50 feet per minute. Ding, 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 there's your slope. So they just handed me the slope, and this is the starting amount called the y-intercept. So we have everything we need in order to write an equation. There's the equation of our line. It's not real hard. I just need to be able to look at the story problem and identify what they give me. In fact, really, there are two situations that they're going to give me. The first situation is obviously a point and a slope. The point magically being the y-intercept. And I can use that, and I can write my equation. And then I can find you anything. You give me, you can, if x equals 3 minutes, how high are we? If y equals 200 feet, how long does it take to get there? These are the types of questions you should be able to answer with this particular equation. So if they give me a number of minutes, I should be able to find the height. If they give me the height, I should be able to solve it backwards and find the number of minutes. But that's stuff that, you know, at this point you should be able to do. If you're having trouble solving either one of those equations, either y equals 50 times 3 plus 12 or 200 equals 50x plus 12, if those are the types of questions you're having trouble solving, talk to me. Okay, we need to get you to make sure you understand how to do that. Now there's another type of situation. Example 2 brings up a completely different type of situation where instead of giving me a slope and the y-intercept, they might give me 2 points. In other words, what they're going to force me to do is they're going to force me to find the y-intercept, or the slope, I should say. And so in example 2, it says a candle is 6 inches tall after burning for 1 hour. All right, so now I have to decide something in this particular situation. Is it time and height, or is it height and time? And I'm pretty sure it's time and height. So time is like your x value, and height is like your y value. So if we wanted to write an equation, they're going to give us 2 coordinates. They're going to say it is 6 inches tall after burning for 1 hour. That's how they quote it, 6 inches tall after 1 hour. So I had to actually put it in my as a coordinate. And then it says after 3 hours, it is 5.5 inches tall. Okay, so now they gave me that information, and they want me to find the equation of the line. Okay, well, first thing I need to do is find the slope, right? Difference in the y values over difference in the x values. So that would be 0.5 divided by -2. And 0.5 divided by -2 would be -1/4. Now, why is it negative? Because the candle is burning. The candle's going down in height. Every single hour it's going down another 1/4 of an inch, according to this. So we are burning 1/4 of an inch per hour. Well, that's the slope, right? That's that whole idea of inch per hour, inches per hour. Like the miles per hour, the gallons per minute kind of thing. Okay, so we've got our slope. Now, I can use the point slope form to start with, but eventually I want to get the y-intercept. So take one of your favorite coordinates. It really doesn't matter. I like 1, 6 just because it's got nice integer values. So I'm going to use 1 and 6 and start using it. So that's -1/4 x plus 1/4. Of course, we want to get rid of that by adding 6 to the other side. So y would be equal to -1/4 x plus 6 1/4. What does this number represent? That is the height of the candle after 0 hours. So that's the height of the candle before you lit it. Now, using the equation from example 2. This will be our last example for right now, and then we'll talk more in class about scatter plots and things like that. When will the candle be? When will it be 4 inches tall? When will it be 4 inches tall? So in other words, we're using this equation to make a prediction. So 4, does that go in for x or y? 4 goes in for the amount of time? No, that's not what they said. It says 4 inches, so that goes over here. That's my y value. -1/4 x plus 6 1/4. So now this is what I'm solving. And obviously I'm going to be bringing that over here, subtracting it to the other side, right? Subtracting 6 1/4 to eliminate that, giving me -2 1/4 equals -1/4 x, and we will do multiplication by -4 on both sides. I know some of you are going to say divide by -1/4, which is the same thing. So then when you multiply them, you get what? 9? So we get 9 hours. Right? That'd be 4 and another. Yep, 9 hours. Okay, we'll talk more in class.